What's up, you freaking geniuses? So in this video, I'm going to teach you how to write complex fractions in standard form. And I'm going to go over 3 examples because there's like 3 different denominators that are kind of weird that you might run into, all right? So we're going to start with kind of the more common problem first. So here we have 2 plus 3i over 4 minus 2i. All right, so we want to convert this to standard form. Now, if you don't remember, standard form looks something like a plus or minus b times I, where a and b are just numbers and I is your imaginary number. Okay, so in order to turn this into something like this, we need to multiply by the conjugate. All right, what the hell does that mean? So that just means whatever you have in the denominator, so 4 minus 2i, we're going to multiply this by the same complex number right here. So 4 and 2i. The only difference is we're going to change the sign that's in between your 2 terms. So here there's a minus sign, so that means here we're going to put a plus sign. All right. Now we're going to multiply by this conjugate on the bottom and on the top. All right. So we're going to put 4 plus 2i on top as well. All right. So now let's extend our little fraction bar right here. Now we're just going to multiply straight across. All right. So you can see we have 2 binomials on top and 2 on the bottom, right? So let's multiply this out. All right, so basically you just have to FOIL. So first we have 2 times 4, which is 8. Then 2 times 2i is positive 4i. 3i times 4 is positive 12i. And 3i times 2i is positive 6i squared, right? So plus 6i squared. And that's going to go all over what we have on the bottom. So 4 times 4 is 16. 4 times positive 2i is positive 8i. Negative 2i times 4 is negative 8i, right? So minus 8i. And then negative 2i times positive 2i, well, negative 2 times positive 2 is negative 4. And then I times I is I squared. All right, great. So now let's just combine like terms. So on top we have 8. And then we have 4i plus 12i, that's 16i, right? So plus 16i. And then plus 6i squared. And then over here, you can see that we have a positive 8i and a negative 8i, so those will cancel out. So we're simply left with 16 minus 4i squared. Okay, great. So now that we multiplied this out and simplified it, the last thing we have to do is get rid of these I squared terms. And the reason for that is because we can, right? So remember, I is defined as the square root of negative 1. Now, if you square I, that's the same thing as, again, square root of negative 1, but now we're squaring it, right? And when you square a square root, or square a radical, the radical and the squared exponent cancel out, and you're simply left with whatever is inside of that radical. So here you can see that I squared would be equal to simply negative 1, all right? So we're gonna replace all of our I squared terms with a negative 1. Okay, so here this is gonna be equal to 8 plus 16i. So this is just an I, right? It's not I squared, it's just an I, so we'll leave that alone. But here we have plus 6i squared. So we're gonna replace that I squared again with a negative 1. And then we're going to put that over 16 minus 4 times I squared. So we'll also place a negative 1 right there. Okay. So now let's just multiply that together. So then this is going to be equal, starting on top right here, 8 plus 16i, and 6 times negative 1 is negative 6. So minus 6. And then on the bottom we have 16, negative 4 times negative 1 is positive 4, right? So then here, combining like terms, 8 minus 6 is equal to 2. So on top we have 2 plus 16i all over 20. All right. So now this is as simplified as we can get it, well, almost. The last thing we can do is split these up into 2 fractions. So first of all, we can split up 2 over 20. And we're adding, right? So we're going to say plus 16i over 20. All right, now you might notice that we can reduce these. So 2 over 20, that reduces down to 1 over 10. And 16 over 20 reduces down to 4 over 5, right? So plus 4 over 5. And then we still have our I term right there. Okay, so now you can see that we finally got our answer in standard form, right? We got our a plus b times I. All right, here's the next example we're going to go over. So here we have 8 plus 6i over 2i. So as you can see, the denominator is different, right? It's still a complex number, but we don't have both parts of it, right? So a plus b times I, here we basically just have the bi part, right? 2i. So in this case, if you wanted to, you could write 0. You could just place in the 0 in for the a. So if you wanted to, you could write 0 plus 2i, all right? So now it's kind of set up in standard form. And then if you wanted to multiply by the conjugate, again, we just have to write the same thing down here, right? So 0 and 2i, we just have to change the sign in the middle. So here this is a positive, here this would be a negative. But as you can see, if we simplify each of these parentheses first, well, 0 plus 2i, that's equal to 2i, and 0 minus 2i, that's equal to negative 2i, all right? So really, all we're multiplying together is positive 2i and negative 2i, all right? So instead of multiplying these parentheses together, let's just say here, the conjugate we're going to multiply by is negative 2i, all right? And remember, we have to multiply by the same thing on the bottom and on the top. All right, so now let's just multiply these all together. All right, so on top, we're just going to distribute this negative 2i into these parentheses. So negative 2i times 8 is equal to negative 16i, and negative 2i times positive 6i is equal to negative 12i squared. Okay, and then on the bottom, 2 times negative 2 is negative 4, and I times I is I squared. Okay, great. So now that we multiplied these together, again, the last thing we have to do is just replace our I squared terms. So here on top, we're going to get negative 16i minus 12 times I squared, and remember I squared is equal to negative 1, and that's going to be over negative 4 times I squared, so we'll plug in negative 1 right there also, all right? So here, let's see, on top we're going to get negative 16i plus 12 over positive 4. All right. Now again, we can split these up into two different fractions. So we can say negative 16i over 4 plus 12 over 4. So here, negative 16 divided by 4 is equal to negative 4. So this is equal to negative 4i, and 12 over 4 is 3, right? So plus 3. And then we can just switch the position of these two, right? So we can write the number first and then the imaginary number at the end. So this is going to be equal to 3 and minus 4i. All right, let's do this last example. So now we have 5i over 2 plus 3i squared. All right, so as you can see, we have this weird squared term right here. So in this case, let's actually just square this and multiply it out. So this is going to be equal to 2 plus 3i times 2 plus 3i. And then on top we have 5i, so then this is going to be equal to, let's see, 2 times 2 is 4, 2 times 3i is positive 6i, and then 3i times 2 is positive 6i, and 3i times 3i is positive 9i squared. And that's over 5i, all right? So then simplifying what's on the bottom, this is going to be equal to 5i over 4 plus 12i plus 9i squared. All right, so now that we simplified this, remember, we always want to get rid of our I squareds. So this is going to be equal to 5i over 4 plus 12i plus 9 times negative 1. So then here in the denominator, it's going to change to 4 plus 12i minus 9. So then you can see that we can combine like terms, right? So 4 minus 9 is equal to negative 5. So in the denominator, we're going to end up with negative 5 plus 12i, all right? So then this is all going to be equal, right, to negative 5 plus 12i over 5i. All right, so now that we simplified the denominator, now we can start converting this to standard form by multiplying by the conjugate, okay? So here, I'm going to actually scroll down because we're going to need some more room, and I'm going to scoot over as well. Oh, that's kind of convenient. All right, so now, like we said, now we can multiply by the conjugate, right? So On the bottom, we're going to multiply this whole thing times this other side, parentheses, right? So here we're going to have negative 5 minus 12i. And on top, same thing, negative 5 minus 12i. All right, so now we can multiply all this together. So again, we're just going to distribute this 5i into this first set of parentheses. So then here, let's see, 5i times negative 5 is equal to negative 25i, and 5i times negative 12i is equal to negative 60i squared. All right, and then that's going to go over, multiplying these two guys. Negative 5 times negative 5 is positive 25. Negative 5 times negative 12i is positive 60i. Positive 12i times negative 5 is negative 60i. And then lastly, 12 times negative 12 is negative 144. And then I times I is I squared. All right, so this is going to be equal to, let's see, negative 25i minus 60i squared over positive 60i, negative 60i cancel out. So we get 25 minus 144i squared. All right, so now we simplified that. So again, the last thing we have to do is just get rid of these I squared terms by plugging in a negative 1. So then this is going to be equal to negative 25i minus 60 times negative 1 all over 25 minus 144 times negative 1. So here we get negative 25i plus 60 over 25 plus 144. So on top, we're simply left with negative 25i plus 60, and on the bottom we get 160 nice, all right? So then the last thing we can do is just split these up into their own fractions. So on the left side, we're going to get negative 25i over 169, and then we're going to add, right, plus 60 over 169. Okay, and again, lastly, we can write the imaginary number at the end. So here we can put this fraction first, 60 over 169, and then we're subtracting, right, because that's a negative number, right, minus 25 over 169i. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.